Chapter 8, Section 8.1 involves percents, taxes, and inflation. Here's what we're going to cover. Of course, percent means per 100. So any percent refers to how many 100th you have in that piece. That's why in decimal form, we always move the decimal over exactly 2 places. So as in this example here, 17% means 17 out of 100, which in decimal form would be 0.17. If you have 3%, that is 3 out of 100. So it's 0.03. If it's under 10%, there's going to be a 0 between the percent, what used to be the percent, the non-zero digits. There's going to be a 0 there because it's less than 10. If you have 125%, that is 125 hundredths, which you'll see this is an improper fraction. This is the same as 1 and 25 hundredths, right? So it's the same thing as 1.25. Over 100%, put in decimal form, is going to have a digit, at least 1, in front of or to the left of the decimal point. So basically, all you ever have to do to change a percent to a decimal is to always move the decimal point 2 places. Exactly 2, never more, never less. Here you could put a 0 in front of the 3. Since it doesn't have a decimal showing, then it's right here. So 1, 2, 3 places would move it 2 places, just like here. Here, there's no decimal showing, so moving it 1, 2, 3 places would make it 1.25. If you had 2.75% and you want to change it to a decimal, don't let the fact that this has 2 decimal places already throw you. The percent is always the big version. The decimal is always the small version of the number. If it's a percent, make absolutely certain you put the percent sign there so that you can tell. So if we're changing this from a percent to a decimal, we're making it into a small number. To make it a small number, we have to move it this direction. So this would equal 0.0275 in decimal form. Remember, it's less than 10%. So it's going to have a 0 between the decimal and the non-zero digits. Anytime you need to write a fraction as a percent, what I would suggest you do is run the fraction through a calculator, divide it out, change it to a decimal, and then you already know how to change a decimal to a percent. According to the Office of Management and Budget in 1970, the U.S. government spent, this should be important, $82 billion for defense when the total federal budget was $196 billion. 45 years later, in 2015, spending for defense was $598 billion, and the budget was $3.8 trillion, which is, let's just leave it in billions. Let's stick with this. 3,800 billion. what percent of the US budget was spent in 1970 and 2015 on defense. Anytime you can write something in the form A is what percent of B. And you just have to figure out, the B is the whole thing. The letters aren't important. We could write B is what percent of A. That's not what is important. When we say A is a percent, that means that A is going to be, generally that means the small part. B is going to be the large part. Now that's not guaranteed because A might be over 100%, but in this case, there's no way that the defense budget is more than the total federal budget. 82 billion is what percent of 196 billion is what we're asking first. So 82 is what percent of 196. And at a glance, I think we're going to get about half, right? 82 is about half. I mean, it's not almost all of it, and it's not a very small amount. It looks like it's a little under a half. Your is always changes to equals. Equals is math for is. So 82 equals what percent, this is our unknown, so we could put in a P or an X or whatever, of generally means times 196. So if we're solving this for P, this tells us we're going to have to divide by 196 to take care of the multiplication. So you grab your calculator and you say 82 divided by 196 is 0.418. I don't see anything here yet saying how many decimal places to go. Always go more decimal places than you might need. It's going to take 2 decimal places to change this decimal back to a percent. So just in case they want some decimal places in the answer of the percent, we need to go 4 or 5 decimal places just to be sure. So let's say it said to go 2 decimal places. First, you change your percent to a decimal. Every single problem that involves a percent in any way, shape, or form, at some point you're going to change a percent to a decimal or a decimal to a percent. In this case, we didn't have the opportunity to change a percent to a decimal because we didn't have the percent. So what the math is going to spit out is the decimal form. And first of all, to change that to a percent, we've got to move the decimal place over 2 places. So that's going to be 41.837%. I was assuming they would want fewer than 3 decimal places, because you got to carry at least 1 more decimal place than you need so that you know you make it, that you know it's rounded off correctly. So 41.837, if they want 2 decimal places, we're going to keep the second, but we look at the third to see whether the second will stay as it is or go up 1. Since the next decimal place is 5 or larger, we go up. So for 2 decimal places, our response would be 41.84%. If they just wanted 1 decimal place, it'd just be 41.8 because the 3 is smaller than a 5. If they just want an even percent with no decimal places, then it would be 42%. Here's another example. A change in price of an energy drink. Anytime they ever want a percent change, and this is going to be one you're going to use constantly, the percent of change means before we divided the number by the whole. In this case, we're going to divide the change by the original number. So a percent increase or decrease. And this one, it's not even saying whether it's an increase or a decrease. Your percent increase or decrease is always the change divided by the original number, the one they were starting from. So in this case, because it went from $18.02 to $19.58, what we'll be dividing by is the 18.02. So the change is 19.58 minus 18.2. And in this case, we can always subtract, saying the larger number minus the smaller. We will give it a sign by calling it an increase or a decrease. So you can't mess this up. The only thing we need to worry about is which number to divide by. And that, of course, we've already decided in this case is the 1802. Now, as usual, this is going to spit out a decimal, not the percent. So 19.58 minus 18.02 is $1.56 divided by 18.02 is 0.08657. 5 decimal places is usually safe. Now, since this is going to be less than 10%, right? Because there's a 0 between the 8 and the decimal place. So to change this by moving it to 2 places, this becomes 8.657%. And then we see how many decimal places. It's going to say next to the answer box how many decimal places to go. So let's say this wants 1 decimal place. If it wants 1, we look at the 1 place, and then to decide whether to go up or leave it, we look at the next place that we're going to drop off. Because the next place is a 5, we're going to go up. So 8.7%. 65 is halfway between 60 and 70. However, they assume that there might be more beyond the 5. We only look at 1 space. So if it's a 5, they round it up. So this would essentially round up to 70, which is going to just be written as 8.7. Here's another question, another example. Monte's Autorama is having an end-of-year clearance in which the TV ads proclaim that all cars are sold at a 5% markup. A markup is the same thing as an increase, a percent increase. It's going up, so we know it's an increase. But it's the percent increase, which means it's the change divided by the original number, the starting point. So on the internet, you find out this model has a dealer cost of $21,339. They're selling it for $23,999. 23,302, what the question is asking, is this at a 5% markup? So you take the change between the prices was 23,302 minus 21,339, divided by where it started, which would be at the 21,339. Don't divide by the wrong number. That will throw it way off. So 23,302 minus 21,339 is going to be 1963. So 1963 divided by 21,339 turns out to be 0.09199, that's 5, which is a percent of 9 point, let's just round this off to 2. So are they being truthful or are they lying? No, this was marked up almost double what their claim is. Here's another example. At one time, the 1995 to 96 Chicago Bulls had the best record in the history of the NBA, with 72 wins and 10 losses. What percent of their games did they win? Now, they're not actually telling us how many games they had. Be careful. It wants to know what percent of the games is win. So win equals what percent of games, or win is. So we could say W equals P times G. So we know they had 72 wins. It's saying what percent, so no point in looking for that. But how many games did they play? They actually played 72 plus 10 because they split it up between wins and losses instead of saying out of 82 games. But we know that this is going to be the 72 plus 10. So we've got 72 equals P times 82. Divide by 82. So P equals 72 divided by 82. 87.8. Well, 0.878. The next one's actually a 0.4. So their percentage is about 87.8%. 88 if they want it to just no decimal places. This is actually taken from Form 1040 for computing federal income tax for a person who is single. The way we compute income tax in the US is what's called a graduating scale. Everyone, once they have calculated how much income they have to pay tax on. So this is after your deductions and everything. This is what's left of your income that you're going to pay tax on. Everyone, whether it's you or Bill Gates, only pays 10% on the first $9,275. So if somebody makes $8,000, they're going to pay 10% on that. So 10% of 8,000, 0.10 times 8,000 is $800. And this should have been withheld, so you're not supposed to have to worry about it. Now, at $9,276, yes, you are bumped up into the 15% bracket. This does not mean you now pay 15% of your income. You still pay 10% of everything less than $9,275. So you only give them 15% of the last dollar that you made. In this formula, this number is how much tax was due on the amount below this, or on that amount actually. So if you made $9,275, you would owe, if we had $92.76, we owe $927.50. That's the amount due on the $9,275, and then you pay 15% of the amount over $9,275. So you subtract your income. Well, this is, I shouldn't actually put $92.76. I should put tax on, perhaps. What you owe is $927.50 plus another 15 cents. So you would owe $927.65. If someone makes, let's bump it up a little, $100,000. What is their tax? Okay, 100,000 puts them in this category. That's between 91,150 and 190,150. So the formula is, don't add the 28% to this. They owe $18,558.75 on the first $91,150 they make. Plus, they are now in the 28% bracket. So plus 0.28, 28%, times the amount over the 91,150. So you have to subtract the 91,150 from the 100,000. So it's 18,558.75 plus 0.28 times $88.50. Now recall, they're paying 10% on the first 9,275. 50%, 15% on the amount that's above 92.75 but below 37,650. 25% on the amount between 37,650 and 91,150, and they've already totaled that up. That's where the 18,558.75 comes from. So now we've got 18,558.75 plus 28% of 88.50 is going to be another 24.78. So they have a total tax bill of $21,036.75. And this is really how it works. So when somebody says, I worked 1 hour over last week and my paycheck is smaller than it was when I didn't work an hour over, I'm not sure what could cause that, but it should not be the federal tax. The Consumer Price Index, this sounds really complicated, but inflation is how much prices rise from one year to the next. There's almost never deflation, which would be prices going down. You might have an individual cost of something go down, but this is talking about the overall, what everybody in the United States purchased or wherever they're talking about. The Consumer Price Index is where they started out in 1982-84, and I believe they assigned that a CPI of 100. Every year, they take the percentage that prices went up and assign each year a CPI based on the percentage that prices rose over that year. These problems sound like it's something really complicated, but it's actually super simple because you can always set them up as a ratio. So in 2015, the overall CPI was 237, which meant that on average, prices in 2015 were 237% of what they were back in 1982 to 84. That means they doubled and then some. So if it had cost $1 in 1983, it now costs $2.37 in 2015. So they want to use the graph to compare the rise in tuition at public and private colleges with the CPI and see if this increase percent was at 237% or above or below. And they're splitting it up between public and private. So if we split it up for public colleges, it went from $971, I guess this is probably a semester, to $9,410. So the percent increase, recall, this is something you're going to use constantly. Your percent increase is going to be your change divided by the original starting point. So the change here is going to be 9410 minus 971 divided by the original number, which is 971. This is going to be way over 100%. So 9410 minus 971 is going to be 8439 divided by 971. Well, it's not quite 10 times as much. This gives me an actual answer of 8.6104, which as a percent would be 869% if I just round it to ones places. So you compare this to the 237, and you want to know how many times more that is? We can take the 869 and divide it by 237 to see how many times more, how many times it went up. And that is 3 2/3 times the average price increase for other things.